Most people who do an OTDR measurement do it using just a launch fiber. The advantage in doing that is you don't have to have somebody at the other end to move the tail fiber across the patch panel. There is a downside to using just a launch fiber, and in this video I'm going to show you what that is. But first, let's set the launch compensation so the length of our launch fiber is not included in our measurement. Tools, set launch compensation, launch only, set, OTDR port is good. We see that my launch fiber is 103.55 meters, so I'm going to store that. Now I'm going to connect it into my link under test. Now I'm going to hit the test key. Again, OTDR port is good. Here's my OTDR trace, and here is my event map. My launch fiber compensation has been applied because it's grayed out, and my measured link here is 53.22 meters. I've connected in, and where I've connected in, I have a great, fantastic loss of 0.08 dB and an awesome reflectance of minus 48.54 dB, where minus 35 is good, minus 48 is even better. But because I didn't use a tail fiber, I don't know how good the connection is at the end of the link. If I tap where the connection is at the end of the link, you'll notice that I don't see a loss value because I didn't use a tail fiber. What you will see is a reflectance value, in this case minus 30.27 dB. That does actually tell us something. On the OptiFiber Pro, where the end of the link is, if the end of the link is in good health, we should see a reflectance of around about minus 16 to minus 20 dB. But here, we're seeing minus 30.27 dB. What's that telling me? It's telling me that I think I have an issue at the other end. And when you see a reflectance value like this, it's normally indicative of a crack in the connector at the far end. So what we'll do, we'll disconnect from this end and we'll connect into the far end of my link. And we will run the test again. So now I'm running it from the far end. You'll notice instantly the OTDR trace is showing something very different here. There's rather a big spike going on here. And lo and behold, I guessed right. Here is my connection at the other end, and my loss is a horrible 1.52 dB, and the reflectance is a miserable minus 16.04 dB. Remember, when we tested from the other end, this was around about minus 48. So I know I have an issue in this connection. When I go and look at the other end, which was the end I was originally testing from, I now see a reflectance of minus 16.23. That's the kind of value you expect to see at the end of the link. It is not the kind of value you expect to see in your first connection. So we now know that we can use just a launch fiber, but there are consequences to doing that. The consequences are we're not going to be measuring that connector at the far end of the link, and we are going to have to go to the other end of the link and retest from that far end. However, when we're testing from just the near end, we can touch the final connection on event map, look at that reflectance, and if it's around about minus 16 dB, feel confident that maybe there's not an issue at the far end. No guarantee. However, if we see a reflectance value of minus 30 dB around that region, then we know that we've got an issue at the other end, and we're going to have to go and fix that. Now, can we avoid this? Sure. When you're doing the installation and you've got the connectors out of the patch panel and you're polishing them or doing your mechanical terminations, you can do a quick check using a product called the Fiber Quick Map. Look on my YouTube channel and see the Fiber Quick Map where I demonstrate this.